Hello. In this video, we're going to examine aggregate expenditures and aggregate production using the multiplier approach. This video takes material from Chapter 10, Part 10.4. That's Learning Objective 10.4. So previously, we learned how autonomous shocks to aggregate demand can ripple through the economy. They can have what some people would call knock-on effects to the economy. So for example, we read about how the revival of the housing market spilled over into other sectors. So when people started building more houses, that meant not only construction goods were purchased, but also more automobiles, more trucks, more cars, more home appliances, more plants, more gardening implements, etc. A spillover effect. Another name for this is the multiplier effect. It tells us that the impact on economic activity, the ultimate impact, can be larger than the initial shock itself. But this is under certain conditions. And one of the main conditions that we're going to be stressing here in this example is that prices are assumed to be fixed. So we've gone through a simple example of the multiplier, but still we need to know, how is it that total expenditures and total output are equal? So in order to answer this question, we're going to do a very simple example. We're going to do a closed economy with no imports and no exports, and when we look at the elements of aggregate expenditures or aggregate demand, consumption, investment, and government expenditures, we're going to be ignoring some of the effects that we had learned in previous chapters. So we're going to keep this very simple. One of our key assumptions is that autonomous shocks to aggregate demand have no effect on the economy's long-run capacity to produce goods and services. Actually, that makes things very simple. There's going to be no changes, no effects to potential output, which means we can focus on only the output gap. That makes things very simple for us. And we're going to find that the output gap must be equal to the non-structural elements of expenditures, that some of which we discussed in previous chapters. And as I already mentioned, we're going to be looking at a closed economy. No imports, no exports. So let's recall our notation. The gap in lowercase is the difference between observed output and potential output. And we're doing this in percent of potential output. So this is the output gap. The non-structural component of consumption we learned about in Chapter 7. It turned out that we learned about certain effects, taxes, and also when interest rate changes. We're going to ignore those for right now, and we're going to focus simply on the impacts on consumption when there's an output gap. We call this the cyclical element, and you may recall that in Chapter 7 we looked at the marginal propensity to save and to consume out of the gap, and we're thinking of the gap as the transitory income for households in the aggregate. So you may remember that the marginal propensity to save is 0.7. That is to say that out of each dollar of transitory income we save 70 cents. That means that the marginal propensity to consume is 0.3, because we either save or we consume. So this is the cyclical element, and it's telling us that we take the gap and multiply it by 1 minus the marginal propensity to save out of the gap. But we also remembered that households often build into their plans spending in response to some economic events or some elements that are not in our model. For example, their house may rise in value, so they may increase their expenditures. They may become temporarily more optimistic. In this case, the autonomous component would be positive. May be temporarily more pessimistic, in which case this autonomous component would be negative. So this is the autonomous shock, or the autonomous component to consumption. Now let's next move to investment. We already studied this in chapter 8. We went into great detail about how interest rates are very important as a determinant of investment, but we're going to ignore those for right now. We're going to omit them, and instead we're just going to look once again at investor or entrepreneurial optimism or pessimism as reflected in the autonomous component to investment. So if firms owners become more optimistic about their firm's prospects going forward, we would have a positive element, and if firms became more pessimistic, this would be negative. Finally, something that we haven't discussed, we will discuss this in greater detail in chapter 16, but we can introduce it right now, is the autonomous component to government expenditures. Once again, these are temporary increases or decreases. So one example is that we might have an election, and as often is the case during elections, governments ramp up, but only temporarily ramp up their expenditures. Then we might also have some temporary, what we call austerity measures, where we decide that we have to cut back temporarily some expenditures. These would be reflected in an autonomous component to government expenditures. So now, the equality. Okay, you may recall that in a closed economy, output is equal to consumption expenditures plus investment expenditures plus government expenditures. Well, here we have the output gap, and it's equal to the non-structural elements of consumption, investment, and government expenditures. And we just discussed those. So now if we take the three equations for consumption, investment, and government expenditures and substitute those into this equation, we get an expression for the output gap. So on the right-hand side, we have the cyclical element of consumption, and then also we have the three autonomous components to expenditures: consumption, investment, and government expenditures. And we're going to be combining those. Here is a graph. Now, on the horizontal axis, we have the output gap in percentage of potential output, and you can see here we have 0. To the left we have negative values, and to the right we have positive values. On the vertical axis here we have the elements of expenditures: consumption, investment, and government. Along this 45-degree line, at any point in time, these three elements must add up to the gap. So this is telling us that C plus I plus G over here is exactly equal to output gap over here. That's why this is a 45-degree line. Now what about this line, this red line? The slope of this red line is actually the marginal propensity to consume out of the gap, because it tells us that as the output gap increases, households will increase their expenditures. And we learn that that's the cyclical component of consumption. Now let's do a little bit more algebra here. Let's go back to this equation here, and it turns out that we have to solve out here for the equilibrium gap. Going to bring it over to the other side, and then also we're going to combine these three guys into an autonomous component. We're going to call this the autonomous shock to aggregate demand, and you'll notice that once we solve out, we get a multiplier term, and it's the same multiplier term essentially that we already had developed. Okay, so now we're going to do the multiplier analysis, and the way that we're going to do this is by going to a spreadsheet. So the first thing that we're going to do on our spreadsheet is we're going to calculate the multiplier. We notice here that the propensity to save out of the gap is 0.7, so the propensity to consume is 0.3, or 30%. So now what I'm going to do is I'm going to calculate the multiplier, and that is 1 over 1 minus the savings ratio. and that'll get me the multiplier. And you will notice that this is the same value that we had been using in our previous examples. Now, what I want to do is I want to examine 3 alternative scenarios. Here's a baseline scenario where the shock is 0. And we're going to calculate the equilibrium gap, and all we have to do is take this shock and multiply it by our multiplier, but it shouldn't be any surprise that that's going to be equal to 0. Under our first alternative, we're going to have an adverse or a negative shock to aggregate demand. Somebody's cutting spending, and that's going to ripple through the economy. So the initial cut to spending is 1% of output, potential output, but the final impact on the economy is going to be that 1% times the multiplier, or minus 1.43%. And you can see here that under alt 1, the line has shifted down from the red solid line to the red dotted line, and you can see that our new output here is minus 1.43, our new output gap, and this is an output gap that satisfies our condition that production is equal to expenditures. Now let's do symmetrically a 1% positive shock, and once again all I need to do is take this and multiply it times the multiplier, and it shouldn't be any big surprise that as a result of this initial 1% increase in spending, autonomous in spending, the final output gap will be 1.43%. Again, the idea here is that initial expenditures rippling through the economy, and ultimately the impact on the aggregate economy is greater than the initial shock. And you'll notice once again, aggregate expenditures equal aggregate output. Now, there's one more note that I think we need to put on this. It turns out that the extra expenditures don't need to be matched 1-to-1 with an increase in output. Instead, what can happen is that firms can draw down their inventories. So we might have an increase to expenditures, an autonomous shock, and in order to satisfy this new demand, firms draw down their inventories. But you remember that when you reduce your inventories, that's actually a fall in investment. So, in a sense, we can satisfy the constraint that expenditures equal output either through more production or through an offsetting fall in inventory investment.